Hello everyone, I am Dr. For Bsc. I welcome you in my YouTube channel. Today in this video, I am going to talk about polynuclear hydrocarbons. So first of all, we should clear the concept of polynuclear hydrocarbon. You can think about word poly, nuclear and hydrocarbon, and then you can analyze what is the meaning of polynuclear hydrocarbons. You know, my friend, a polynuclear aromatic hydrocarbon is a hydrocarbon made up of fused aromatic ring molecules. These rings share one or more sides and contain delocalized electron. Another way to consider FAS, P for poly, H and A. So polynuclear hydrocarbons is molecule made by fusing two or more benzene ring. So polynuclear hydrocarbon, aromatic hydrocarbons molecules contain only carbon and hydrogen atom. That is important. Now, properties. Polynuclear aromatic hydrocarbons are lipophilic. What is the meaning of lipophilic? Non-polar molecule. They tend to persist in environment because FAS are not very soluble in water. While 2 and 3 ring FAS are somewhat soluble in aqueous solution. So the solubility decreases nearly logarithmically as molecular mass increases, and 2 and 3 and 4 rings FAS are sufficiently volatile to exist in the gas phase. So my friend, larger molecule exist as solids. Pure solid FAS may be colorless, white, pale yellow or pale green. What is the sources? FAS are organic molecules that form from a variety of natural and environmental pollutant reaction. Natural FAS form from forest fires and volcanic eruptions. The compounds are numerous in fossil fuels such as coal and petroleum. Man contributes FAS by burning wood and by the incomplete combustions of fossil fuel. The compound occur as a natural consequence of cooking food, particularly when food is cooked at a high temperature, grilled or smoked. The chemicals are released in cigarette smoke and from burning waste. So these are the sources from which we are getting the FAS. Now we have to think about health effect. You know, my friend, polynuclear aromatic hydrocarbons are extremely important. Why? They are associated with genetic damage and disease. Also, the compound persists in the environment, leading to increased problems over time. FAS are toxic to aquatic life. In addition to toxicity, these compounds are often mutagenic, carcinogenic, and teratogenic. Parental exposure to these chemicals is associated with the lowered IQ and childhood asthma. My friend, you know, people get exposed to FAS from breathing contaminated air, eating food that contains the compound, and from skin contact. Unless a person works in an industrial setting with these chemical exposure tend to long term and low level, so there are not medical treatment to address the effect. The best defense against health effect from FAS exposure is to become aware of situations that elevate risk: breathing smoke, eating charred meat, and touching petroleum product. Now, my friend, classifications. What is the classification of polynuclear hydrocarbon? You can see the polynuclear hydrocarbons, two types, benzenoid and non-benzenoid. One is isolated, another one is fused. You can see the examples, biphenyl. You can see the fused one, naphthalene and phenanthrene. So, we will focus on naphthalene. You know the molecular formula of naphthalene C10H8 means in naphthalene there are 10 carbon and 8 hydrogen. Count it. So, aromatic hydrocarbon in which two benzene rings are fused in ortho position. For the purpose of naming its derivative, the position are indicated by figures. You can see how you will do the numbering scheme in naphthalene. How you will isolate naphthalene? One isolations you can do from the coal tar. Naphthalene is the largest single compound of coal tar, about 6 to 10%. You know, the hydrocarbon was first noticed as deposit in the condenser during the distillation of naphtha fraction, and hence its name, naphthalene. It is obtained chiefly by cooling the middle oil fractions about 160 to 230 degrees Celsius, whereupon naphthalene crystallizes out. The crude crystals are removed by centrifuging. These are the melted and then treated successively with concentrated sulfuric acid to remove phenols. Finally, the naphthalene is sublimed to give the pure products. Now, what is the properties of naphthalene? You know the physical naphthalene is a white solid which crystallizes in shining plate, melting point 80 degrees Celsius, boiling point 280. Having a strong odor, it is very volatile and sublime. Readily on warming, naphthalene is insoluble in water but dissolved easily in organic solvent, particularly in ether and benzene. Now, you know the chemical properties. The reaction of naphthalene are essentially the same as those of benzene. It undergoes substitution readily and form addition product. However, it is somewhat less aromatic than benzene. That is very important. Thus, the double bond in naphthalene exhibit in part the reactivity of alkenes, and it forms addition compounds more readily than does benzene as soon as one of the ring is fully saturated by additions of hydrogen or halogens. Now, resonance structure of naphthalene. You know the X-ray diffraction study shows that unlike benzene, all carbon-carbon bonds in naphthalene are not of the same length. In particularly carbon 1 and carbon 2 bond is considerably shorter than C2 and C3. And this difference can be understood if you examine the three resonating form given above. Notice that carbon 1 and carbon 2 bond is double into a structure, single in one, whereas the C2-C3 bond is single into a structure. So, double bond is only one C. We would therefore expect the carbon 1 and carbon 2 bond to have more double bond character, shorter bond length, and carbon 2 and carbon 3 bond to have more single bond character, longer bond length. Now, the resonance structure of naphthalene is about 61 kilocalorie per mole, and this value is less than twice the amount of single benzene ring. As a result, naphthalene is somewhat less aromatic. Keep in your mind and write it down. Naphthalene is somewhat less aromatic, more reactive. Less aromatic, more reactive than benzene. So, look at here. Structure A, structure B, and structure C. Now, properties of naphthalene. How you will synthesize naphthalene. So, from 3-benzoyl propanic acid, when 3-benzoyl propionic acid is heated with sulfuric acid and alpha naphthol is formed, which on distillation with zinc dust forms naphthalene. So you can see how 3-benzoyl propionic acid converted into 4-phenyl butanoic acid. Then from 4-phenyl butene you will get naphthalene. Now Howard synthesis, it involves 5 steps. Benzene react with succinic anhydride, it gives 3-benzyl propionic acid, and then reductions in the presence of zinc amalgam, it gives 4-phenyl butanoic acid, and it react with the sulfuric acid under heating, it gives tetralone, and tetralone is treated with zinc amalgam, it gives 1, 2, 3, 4 tetrahydronaphthalene tetraline, and it react with the palladium in heating, you will get the naphthalene. So this is the structure of it. Now reaction of naphthalene. You know naphthalene is more reactive than benzene. It undergoes several reactions like oxidation, reduction, addition, nitration, halogenation, acylation. So oxidation of naphthalene. You can see with KMnO4 it gave phthalic acid, with basic medium it gave phthalonic acid, with canoic acid it gave 1,4-naphthaquinone, with ozones it gave phthalaldehyde, and with sulfuric acid it gave phthalic anhydride. Now reductions of naphthalene. You can see naphthalene react with the hydrogen nickel catalyst, it gives tetraline and it gives decaline on further reductions. Sodium methanol, it gives 1,4-dihydroaniline, and with nickel it gives decalines and tetralines. These all products are reduced product. Now addition reactions. You know naphthalene undergo additions, it gave 1,4-dibromonaphthalene and 1,2,3,4-tetrabromonaphthalene. You can see naphthalene undergo chlorination, it gave alpha-chloronaphthalene. Now electrophilic substitution reaction. You know naphthalene like benzene undergo electrophilic substitution reaction. Substitution occurs primarily at carbon 1, which is the alpha position, and this can be understood if you examine the intermediate carbonium. 2 resonance forms can be written for the intermediate carbonium ions obtained from the attack at carbon 1 without involving the other ring, whereas only such form is possible for the substitution at carbon 2. E plus is the following equations represent the electrophile. Look at here, attack at carbon 1, it gives the more stable resonating structure here and product in one substituted product. If attack at 2, less stable and 2 substituted product. So the former intermediate is more stable and product with a substituted at carbon 1 predominates. Substitution at carbon 2 beta position occurs only when the reactions are carried at higher temperature or when bulkier solvent are used. So first nitration, you can see the alpha nitronaphthalene. Second chlorinations, alpha chloronaphthalene. Sulfonations, low temperature it gave naphthalene 1 sulfonic acid, high temperature it gave naphthalene 2 sulfonic acid. Friedel-Crafts alkylation. Friedel-Crafts alkylation at low temperature is carried out for naphthalene, which reacting with the iodomethane to produce 1-methyl naphthalene as major product. You can see. Friedel-Crafts acylation, you can see the naphthalene it gives the methyl 2-naphthyl ketone and methyl 1-naphthyl ketone. So derivative of naphthalene, these are the important derivative of naphthalene: naphthalene 1-ol, naphthalene 1,5-diol, and 4-amino-3-hydroxynaphthalene or 1-sulfonic acid. What is the medicinal use of naphthalene? You know the production of naphthals, production of dyes. This dye is phenyl azo beta naphthol red dye. That is also preparation of beta blocker drugs and to synthesize synthetic dyes and useful insecticide. And veterinary medicine dusting powder, polyethylene naphthalene to prepare plastic bottle, naphthalene sulfonic acid are used to prepare plasticizer, mutual rubbers, naphthalene drug to cure cough, urine infection, eye trouble. So my friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.